Section 4.4, day 2, which also happens to be our last day of chapter 4, continues working with the unit circle, continues solving trigonometric equations. A couple new things today, but big picture not new. I'm going to use the variable x instead of theta. Hopefully you guys have figured out it doesn't matter what symbol you use for the angle you were trying to find. While we're on that topic, remember the big picture as well. When you're solving a trigonometric equation, you're really trying to say, what angle or angles could you insert for x and the equation would work? So if let's make up an answer that I know is not right, 47 degrees. Could you put a 47 in place of x? Go sine of 47 squared plus 10 times sine of 47 plus 9. Will it equal 0? Now that's not going to be one of the answers, but that's essentially what you're looking to do. Now, here's our second day in a row of doing some factoring. When you look at this equation, you are nowhere near your happy place. You're nowhere near using the unit circle at this point, so we have to prep it. So I always used to say you're living under a rock if you don't look at this and think, I gotta factor it. So when we start the factoring, don't panic just because it has a sign and another sign. If you need to, and I'll write it down once and erase it, you could take the signs away, use just x's if that calms you down, and then you look at this and you think of the factoring and you're like, oh, okay, I got it. It's x, and then what multiplies to 9 that adds to 10? Well, it's a plus 9 and a plus 1. Same thing here. It can really help you relax a little bit in factoring something that has trig in it. And if you need to, FOIL this back out to double check and it will work. Now, we're at our swoopy swoop and we're very close to our happy place. When we do swoopy swoop, we used to just bypass this moment in our previous course where we would just jump right down to what we knew we were supposed to have. Here you may want to write it down. Sine x plus 9 equals 0. Bring the 9 over. In this one, sine x plus 1 equals 0. Bring the 1 over. And now you're at your happy place. Now you might be thinking, this I'm pretty happy with, this I'm very unhappy with, but you got to trust me, this is a beautiful one. This guy right here has no solutions. If you use your calculator and you went second function sine of -9, you'd get an error. This is our last day of chapter 4, and when we start chapter 5, the graphs of sine and cosine, you will see automatically, oh, this just never was going to be a candidate for something that would work anyway. So this is actually a happier place. This one, pretty happy, but requires a little bit of work. What we have to do is remember, sine is y over r is always 1, and we go to our unit circle. So where would be the y value that gives us a -1? So we have to look here at the quadrantal angles. 0, no, not 90, close, but no banana. Nope, got it, 270. Now, in this guy, just a couple of quick notes. 270 degrees is definitely one of the answers. We are supposed to answer in degrees, not radians, because of the stipulation here. If it was radians, well, then you're just going to look at your unit circle and say it's 3 pi over 2. Now here's where there's one little change. Again, this doesn't happen much, but the odd time it does, we have to be ready for it. What we are allowed to do is go up to 360 and not beyond, but we can actually go backwards to -360. And if we can find a spot where the y value is still -1 in a negative angle, it still is an answer that would work in the equation. So if we start at the positive x-axis in standard position and work ourselves backwards, it would go like this: -30, -45, -60, -90 is the key. At -90, we still have a y value of -1. So now we have a second answer for our first out of 2 problems. The last example of the day gives us a tangent equation. You know what is coming. We are going to factor this guy. And just because there's something brand new again coming here, I kept it in degrees. We're going to work from 0 to 360, so nothing crazy. We don't have to worry about negative angles. We begin very innocently. We look at this, and we have to be thinking, let's factor it. And it factors to tan, and then it's really a simple sum and product. What multiplies to 4, that adds to 5. It would be a +1 and a +4. We swoopy swoop each one. So we're going to have tangent of x, And some of you might do this. Some of you might jump to just tan x equals -1. That's fine. If you need to, you can still write it out. This is really formally what we've always been doing since pre-calc 20. Tangent of x plus 4 equals 0, and then bring the 4 over, and let's get our solutions. The very first one, okay, you might be thinking, oh, tricky, but you won't catch me this time. So tangent is y over x. We're looking for where is a tangent of -1, and this is what I do still to this day. I always look with the ones at the quadrantal angles, like 0, 90, 180, and then very quickly I'm like, nope, because tangent y divided by x will either be an error or a 0 there. Then I realized, yep, it's at the 45 ones. 45, 135, 225, 315. The y and x are the same. Anything divided by itself is 1. We're trying to get a -1. So my two key spots are going to be 135 and 315. So I have two solutions. Now, to end our day, this is where you're going to want your calculator and you're going to want it in degree mode. If we refer back to example number 1, when we had sine of x is equal to -9, we wrote down no solution. And I promised you in chapter 5, graphically it'll make amazing sense. Your instinct would be to write down no solution right here. But there is actually an answer. And sorry I forgot the x here. If you go second function tan of -4, and I'm just going to round to a whole number, you will get 104 degrees in your calculator. And then you're going to be left wondering, well, how? How did this work and the sine didn't? You got to be patient. In chapter 5, it will be fully explained. This one actually did have an answer. And again, graphically, it'll make perfect sense. But we just got to wait for chapter 5 to begin. Here's where we end. But you're going to end on a spot where you have to think pretty hard. 104 degrees is one of the solutions that might work. So if we come out 104 degrees would be somewhere in the second quadrant. But that might not be the only answer that gives this value of -4 and -10. And so what I do is I drew a quick little diagram. And I might have overstepped myself. Your calculator might not have even spit out 104. Here's what we need to look at. We need to really look at what are reference angles. That's an old definition, but one that we've seen before. So 104 degrees is one of the answers. How many degrees is it to the nearest x-axis that's a reference angle? That is 76 degrees. So here's what it actually means. There's going to be 4 angles from 0 to 360 that all give you a 4, or very close to a 4 because we rounded the angle off. If I go 180 plus 76 right here, that is 256. If I go 360 minus 76, that is 284. If you took your calculator and typed in tangent of 76 and hit equals, or tangent of 104 hit equals, tangent of 256 hit equals, tangent of 284 hit equals, they will all give you 4, or really close to 4 again, because we're rounding 104. However, which give a negative value? It is 104 and 284. They are negative tangents. If you think y divided by x, a negative divided by a negative wouldn't work here. A positive divided by a positive wouldn't work, but it would work there. So now we have our two answers, 104 and 284. So quite a new finish. We've never seen that before.